I've been working with the Institute for Manufacturing for probably the last 2 years or so on a number of different projects, and I've also been working with a couple of PhD students. And what I wanted to do was bring Aanand in on 2 of the different projects we've been working on, and for Aanand to talk about some of the results that he's seeing on energy modeling for eco-efficiency. I wanted to have just 3 very small agenda points. The first one is presenting a method of operational energy modeling. Aanand will go into the more scientific version of that. 2, I wanted to look at helping manage and make informed decisions, because it's no use modeling if you can't get some decision-making processes out of it. And out of that one, we look at practical energy management. So I wanted to give you some practical examples and some of the paybacks that we're seeing out in industry. So a bit of academic, but also a bit of practicality, because at the end of the day, energy management and sustainability needs to be sustainable. And we need to create sustainable wealth within any industry. So in order to do that, what we see is not energy management as in we're talking carbon or we're talking cost. We're looking at 4 different areas. We're looking at economic drivers, we're looking at environmental drivers, but 2 that we're seeing more and more, and a lot of companies aren't talking about this. One is the increase of quality, that's quality of finished product, and 2 is the performance of factories, which is very, very much the heart of sustainability. I'm not going to go into huge amounts of detail about that. What I'd rather do is hand over to Aanand and some of the things that he's actually talking about and doing.
Thanks, Craig. So, ladies and gents, basically what myself and Craig and members of the EPV team who are outside today are trying to do is to help you make modelling part of an integrated part of your process, and to develop it as an iterative tool that's easy for you to integrate with what you already know about what's happening on your shop floor. So we're looking at things that you hopefully already have a bit of an idea about, like your energy and materials being input, and the material transformation that happens on your shop floor across your processes, and what outputs you're getting from that. And the modelling feedback loop that occurs there, we're looking at things like how you capture the data, how you can model it through the different levels and the different slices, the types of results you get, and how you can implement those, which Craig will pick back up on at the end, and how you can then remodel and develop routines for continuous improvement. So ways that you can capture data, or ways that we've been capturing data over the last 2 years, are pretty varied, and you get different levels and different granularities, as we like to say, within the modelling kind of arena of data, and those different levels can give you different amounts of output. So we work with a number of different companies that have highly evolved systems where they have SCADA in place, and SCADA being supervisory control and data acquisition systems, and they have lots of sensors on all their machines. But we also work with SMEs who don't have the capital or the existing technology there to invest in those sorts of things, to model and measure their equipment and their efficiency. So what we do is we actually start with very cursory bits of data, such as your energy bills, your production schedules, things that you have on paper, and then eventually develop that into the kinds of more detailed data from SCADA and sensors, if need be. So I just thought I'd give you a quick sample of the types of cursory models that you can create, and this was literally created from a series of different utility bills. And the idea is that this kind of shows you at a very simple level what is going into and coming out of your system, and hopefully, as you can see here, you've got a lot of resources going in for a pretty small amount of product coming out at the end. And the point of that was to say, right, we can understand that there's a lot of materials going in at this level, which is your kind of factory gate, what's going in to my facility level. And we then broke this down, and I purposely haven't put images in to show you the breakdown of this, because I want you to come over to my poster stand and have a look at it. But the idea is you can then break that down into the different zones within your factories, and also the different bits of equipment and different processes that occur and different operations that occur within that process. So there's lots of different levels that you can break this data down into. And to just give you a quick overview of, again, a little sample of the more detailed types of modelling. This is showing an energy breakdown for a paint shop for one of the automotive firms that we're working with. And what we've done here is we've actually created a scaled Sankey style diagram that shows your energy breakdown and also your water breakdown across this process. And the other thing that we're intending to do is develop statistical distributions within our simulation tools that actually model that for you. Oh, skipping along there instead of pressing play. So what this visual is actually showing is it's showing a lot of boxes, but those boxes are actually representative. So the red is representative of energy, whereas the blue is representative of water. And the idea is that you can see as product goes along your conveyor, you have a certain amount of energy being delivered to your process in order for that product to be transformed, that material to be transformed. So what we're trying to show in this is the dynamics of the system as data is being fed into it, basically. So we're doing that for energy resources and also for water and other resources that you have going into your system. I'll let Craig take back over for this bit, the important bit.
I think what Aanand shows is something that's a little bit more than just looking at a lot of graphs for energy management and resource efficiency. One of the things that really excites me is being able to visualize some of that energy. And typically what we use is standard systems to do that. We use the typical graphs. We use things like power factor. We use thermography, which if you go and have a look at some of the things that especially at Loughborough are doing, those are all very good visualization tools. But at the end of the day, one of the things that we find quite interesting is being able to model it and show the end user something that's a bit more animated, something that says, well, actually, here's a spike in your production, and it might be not because your quality of paint has gone, but it might be because the weather's changed, or it might be because some other attribute. And that's something that the visualization and animation can do, and which is what Aanand is looking at. But taking that from a theoretical point of view to a practical point of view, we see three things that come out of that. One is you can change your business processes. Two, you can go do a technical intervention, which to you and me is put a timer switch in. Or three is to actually go and do a mass capital replacement project. And in reality, you're probably looking at the first two is the type of things that you do in a normal manufacturing or industrial area, and leave the capital equipment side of it to the end. And for the simple reason is everybody says, well, that's very, very financially intensive. But what we've seen with when you go down a sustainable side of things, and I want to use this as an example, we decided on the paint shop within a manufacturing facility, but we found something else in the paint shop. We looked at the lighting, and there's been a lot of talk about lighting and LED and that in industry, and everybody's going through big projects. And there's some really good savings, about 60% savings in energy. But what people don't realize is actually there's a couple other things that change when you start looking at lighting in a process, not in a facility, but in a process. The one of them is this graph over here. I found in business there's two types of graphs. There's a sales graph, which needs to go up, and then there's the financial or the quality, where your quality is increasing, so your defect rate goes down. So production and finance all want to go down. And this one here shows that we did a particular process. We changed the lighting systems. We standardized on a particular set of attributes, and we got a 20% reduction in the parts of dust per vehicle that's going through. Now, anybody in an automotive industry can actually equate that back into cost savings because it doesn't go through the plant again, and you don't need to do that. There was another one which was, we thought we couldn't actually capture this data, but we actually managed to capture this data, was the working conditions. And those two thermography pictures there, one of them shows a picture of the ambient temperature, which is roughly at about 40 degrees. So you put your hand on the wall and it's roughly about 40 degrees. 10 days after we did the project, we came back and we actually measured the temperature, and it had gone down to 27 degrees. So sometimes a bit of sustainability, and when you're looking at energy reduction and all that, can give some really interesting other examples out of there. And the last one, which I like, is we've managed in that process to reduce 56 grams of mercury out of the process by reducing the amount of fluorescent lights in there. Now, that is, if anybody's books, that is a really good story, because you take 56 grams of mercury and put it in your hand, probably in 6 days' time you won't actually be alive. But taking that as a small project, one of the other things that we're seeing with modeling is being able to get the continuous improvement. And sustainability is a continuous improvement. And this just shows you over a 12-month period. Aanand's been in and out of one or two of these projects. But at the end of the day, in one particular plant, we took roughly about £500,000 worth of energy out of the particular plant without having major capital investment, and looking at it as saying, as this is continuous, this is small processes, this is step by step by step. And I know most organizations out there, and most environmental sustainability or energy managers will all tell you, take those small steps. And with modeling, and with what Aanand and some of the other guys are doing, it allows you to take those small steps without actually using those big capital intensive projects. Aanand, do you want to take it?
Yeah. So, I mean, as I mentioned to you guys earlier, we work with a range of people. You know, they can be large firms, they can be small firms, they can be looking at, you know, you could be looking at cars, you could be looking at planes, you could be looking at plastic and rubber manufacture. But the point is that the lessons that you learn from one and the types of modeling and the types of efficiencies you might be looking for could be applicable to many of those across the board. So if you guys are interested in finding out about some of the stuff we do, come and have a word. Cheers.